Today's lesson is 93. It's equations with exponents. What's our objective, class? Get ready?
Equations with exponents.
Very good. I like how you guys have your notes ready, and we have to remind you guys are already penciling our title in, so great job. Today's lesson, we're going to learn how to solve equations involving exponents by taking roots of both sides of the equation. And then we're going to make sense of the solution, because you're going to find out today, it says solutions. We're going to work on equations. Because of the exponent, there's going to be more than one solution. So at the end, we'll decide on which solution makes sense. When we're talking exponents, today we're going to deal with exponents of power 2. What power? Get ready?
2.
2. If the highest power in the equation is a 2, it's called a quadratic equation. What?
Quadratic equation.
A quadratic equation. And it has to do with quadratic, meaning four-sided, like a square. Think of a four-wheeler, 4 sides. Quadratic, there's 4. So if I told you a square had an area of 25, you would know each side length would be, you would take the square root, right? The squared and the square root are inverses of each other, so they cancel each other out. That gives me x alone, and I know the side length is 5. And I know if I was talking the length of a square, it would be 5. But there is one other number that could solve a number squared that equals 25. What other number could that be? Winry. Negative 5. And that's what our lesson really is about today. Because negative 5 squared is also 25. Positive 5 squared is also 25. So there are 2 solutions. How many solutions? Get ready?
2.
2 solutions. So any quadratic equation is going to have 2 solutions. Let's look at it right here. 2x squared plus 7 equals 25. Let me get rid of that gray. Let's see if we can get that to go away. Good. Okay, using inverse operations, we need to isolate x, just like we've done before. We need to get rid of the 7. We're going to peel back our onion to get down to the x, but we have to start farthest away, so we get rid of the 7 by subtracting. To keep a balanced equation, we do it to both sides. We get 2x squared, bring down my equals. 25 minus 7 is 18. Now, I got to decide, should I get rid of my squared first, or should I get rid of the coefficient first, the 2? And how do you know? Ethan?
Well, you probably want to get rid of the coefficient first because we don't know the square root.
We don't know, yeah, and we also don't know the square root of, we can't square it very easily. We'd end up having to square the 2 as well. Think of Pemdas in reverse. It goes parentheses, exponents, multiplication, division, addition, subtraction. So if we undo things, we have to go backwards. And so Pemdas, spelled backwards, it says to go multiplication, then exponents. So we're going to take care of the multiplication, then the exponent. So in backwards. So we're going to get rid of the 2 by dividing, because it cancels into 1. I'm left with x squared equals 9. And thank goodness we can finish it here.
The square root of 9 is 3, so x is 3.
That's one of the answers. So again, we're taking the square root. 2 cancels with the square root. We're left with x equals plus or minus 3. Okay, the square root of 9 is plus or minus 3. What is the square root of 9? Get ready?
Plus or minus 3.
Plus or minus 3. There are 2 answers in a quadratic. How many answers in a quadratic? Get ready?
2.
2. So this is your key. Oh yeah, this is one of those quadratics. I got to make sure I include a plus and a minus. What happens though when you can't take a perfect square root? Let's try this one. We know before we work on the power, get rid of the coefficient. We're doing Pemdas backwards. So multiplication. We do the inverse, which is division. We get x squared equals 8. Now we take the square root. The squared and the square root are inverses of each other, so they undo each other. We get x equals plus or minus square root 8. But I can't take the square root of 8 and get an integer answer. But can I, just set it on my desk, but can I write root 8 in a more simple way? Like a simplified way. We learned this last couple weeks ago. Lexi?
So can you do like you break it apart like we did? So you could do 2 and 4 because 4 has a square root of 2.
Perfect. So we're going to break it apart, find its factors. So the factors of 8 are 2 and 4. And then I take the square root of each one. Now listen real close. I've had students mess this part up all day today because they get confused here because they just try not writing it down. 2 times 4, root 2 times root 4. Can I take the root 2 and get an integer answer? No, so just leave it alone and leave it root 2. Can I take the square root of 4 and get an integer answer? Yes, Kaylee. It's a 2. Okay. Bring down my plus or minus. But I don't like writing it like that. I like the coefficient in front, so I'm going to say plus or minus 2 root 2. And that's my answer for x. I should say that's my answers. That we've never seen an answer look like that before. But there are 2 of them, positive 2 root 2 and negative 2 root 2. Let's prove it. Let's check. Is 2 times the positive 2 root 2 squared equal to 16? Well, I'd have to square my 2 and get 4. Square my root 2 and get 2. Does that equal 16? 2 times 8 is 16. So that works out. Let's try the negative version. Okay, what if I had negative 2 root 2 and I squared that? Well, that's going to be negative 2 root 2 times negative 2 root 2. Negative 2 times negative 2 is 4. Root 2 times root 2 is 2. And I still get 16, right? 2 times 8. So that's why I've got 2 answers, a positive answer and a negative answer. Give me a nod if it makes sense and you're okay. Nicely. Okay, Avery, we're there. Okay, let's try this one. This one doesn't at first look like a quadratic. Wait, Mrs. Boone, those are fractions. You said it has to have a squared to be a quadratic. Why is it in this lesson? Well, a proportion, we do something. Jasmine?
Cross multiply.
Cross multiply. So wait, you're saying 16 times 9 on the left side, on the right side, x times x. And then we simplify, that's 144. X times x is x. There's our quadratic. Quadratic's going to have how many answers? Get ready? 2. So we're going to square root both sides. Root. As soon as you do that, you can go ahead and put your plus or minus there so you don't forget. The 2 and the root are inverses of each other. They undo each other. So you're left with x. And we get plus or minus 12. Oh, did you want to say it? Okay, you can say the next one. Okay, good. Last one. Example 4. This is where we have to decide contextually if we have both answers, which answer makes sense. So Jamie's making a mosaic using 101-inch square tiles. You guys know what a mosaic is? Who knows what a mosaic is? Aubrey, what's a mosaic?
It's an art piece of like tiles.
Yeah, like a bunch of tiles, right? Mm-hmm. I've been to the Vatican in Rome, and they have like 40-foot tall mosaics that are made of like little pieces of tile that's like the size of your pinky in like a billion colors. And so that makes pictures of the prophets and apostles and stuff. It's really cool. So Jamie, anyway, she's got a bunch of little tiles in here. You know, like they're all, does it say what? Oh, they're square. Jaime? What? Jamie?
That's Jaime.
Jaime? Can be both. Okay, but anyway, there's 100 inside. Question is, how long should each side be? Well, you know it's 10, right? But looking in the quadratic sense, we would square root both sides. Squared and square root cancels. We're left with x equals plus or minus 10. But in this case, can you have a negative 10 length on a square? It doesn't make sense to have negative lengths. So that's why in this case, we eliminate the negative and we just say 10 tiles. So make sure, just in context, you know when to include the positive or the negative. Okay, any questions? All right, we're on page 626. Take a stand-up break and then I'll get you your practice set problems.